So in this video, I will look into this competition again, UW Madison GI tracked image segmentation, on which I did a previous video of implementing UNet to segment intestine from the stomach. Hello, my name is Rohan-Paul and very welcome to my computer vision and deep learning YouTube channel. Let's get started. And in this video, I will just implement a simplified functionality of decoding the run length encoded mask value from the images, and also to plot the mask by wrapping it around the images. And the important thing to note about these RLE decode and why I need that is because if I look into these data tabs train.csv, so this is the main CSV file which has all my image IDs, etc., that we just described. And if I go down, the segmentation column has these mask segmentation represented like this. So these numbers actually represent the position and the run length of the mask that has been detected in the images. And this is the RLE encoded version, and which we discussed in the previous video. And to read from these code, that is to actually get the images of the mask, I have to decode these encoded numbers. So here I am back in my VS Code. I have already downloaded the entire dataset in my local machine. So in this cell, I'm just reading these file train.csv and printing the data frame. And this is the file format that I have ID, class, and segmentation. And again, these segmentation, these numbers are all RLE encoded. So let's, I'm just going to define few list variables before I do anything. So I have my train root dir, and I'm going to use rglob, which is almost like glob with a little subtle difference. To that, I have to pass the position of the file, and here my files are all in let's quickly look at the train image input data set. So I have my train directory, then inside I have the case number, then I have case and day, and finally scans, and then inside scans all the scanned images. So I have 1, 2, 3 and 4 subdirectories. So let's include that. That should do. Let's try to quickly print list images here, and let's see what do I get. And as expected, I got just a map object here. Because this is rglob, I cannot directly print it like this. I have to convert it to a list and print the element of the list. So let's define an x variable, and for p in train root dir. Actually, I do not need to do that. I can just do p in list images, and that should what happened, it should print. Oh, I need to just print the x. Still did not print. I think I need to correct it here. I think I'm just going to restart this notebook and run it all together again. Yep. Now it ran well. So these are my actual images from the train directory, and now I have to work with them. So let's do, first I'm going to create a data frame, and for that I need the separate elements of these names. That is, I need one data frame column named as my image file name, which will have this complete thing. Then I need another data frame column which will have the case and the day number. That means this. So I first need to split these entire string by these slashes, forward slashes, and then take different element. I need the actually I here the first element will be the entire string, then c dot split split by, and take the -3. What this will do, okay, let me do it first and then I'll explain. -1. Images, and my column names will be no. We've got case and day, and the last one will be image file name. So basically these first part, it is splitting and then taking the third element starting from the end, which means my third element starting from the end is 1 2 3. So this will take my case number, which is this column that I just defined, and this -1, that is I'm splitting by forward slash and taking the -1, that is it will take the last element, which is this entire thing, that is a full file name of the image. And the first that is only C, it is actually the entire path, which is what is taken by this column name full path. And if I just print image editor dot head, just print 2, that's what we get. This new data frame, I have these new column names, case and day, image file name. All right, now I'm going to add few more column names for slice, height, width, and id. Lambda function, and I'm going to split these x and take the 1th element to be my slice. So let's split by the delimiter of the underscore. Sorry. And then take 1. Do the same for height. And for width, also I need the ID, but this will be different. I have the ID. Yes. ATTR slice. Now let's merge the original DF with this new image ATTR data frame. On ID, I'm getting a key error, and that's because let me fix it. Of course, I did not run this cell at all. So all these new columns that I just created, they were not actually created. I did not execute this cell. And now run it. What's the problem now? Oops, I never put the head here. Awesome. So that's my newly merged data frame, but I wanted to check a sample of them. Yeah, looks all right. And that's how my newly merged data frame looks like. And now I'm going to plot some random images um, from my training data set. So I'm just creating these list images variable again. Actually, I don't need to create that. Just num columns. Let's put both num rows. They are 6 and 2. No. Why this is not taking automatically my intelligence in the code? Yeah, now it's taking 24 and 9. Images will be equal to, I'm going to choose with random.choice. The choice says list of images, and the key, this parameter is an optional parameter that is used to define the length of the returned list. And in my case, it will be the total size of the grid, that is width into height, that is number of columns multiplied by number of rows. Num columns times num rows. And now my loop for plotting the images. So num images in enumerate images are equal to, that will be num then modulo columns, j will be equal to num / num choices, num columns. Yeah. So here what I'm doing basically is that these are the index values of each of the images. So that means it will start from 0 and end in 12. And why 12? Because we have total of 6 into 2 number of images. That is total number of column 6 and number of rows 2. That means we are going to plot 12 images, and so this index number will loop through a value of 0 to 11, and then this I and j, for this number, the I will be the each index number across. That is, when I'm having 6 columns, that means the value of I will be from 0 up to 5 for the 6 columns, that is 0 1 2 3 4 5, and the value of j will be the that will be to index the rows. So that means for the first row the value of j will be 0, and for the second row the value of j will be 1. And again, this is doing by these operation num / num columns. And in here, this double forward slash is the floor division operator in Python. It produces a floor of the quotient of its operands without floating point rounding for integer operands. And this is needed because in Python 3, the ordinary single slash division operator returns floating point values even if both operands are integers. So a different operator is needed for the floor division so that I get an integer after the division. I need to convert this image to a Numpy array. So, and then I can get my axis. Actually, I want to just keep it axis object.a. For the title, I need to get the case and day number from the image. Strip by stance and then split by the delimiter of forward slash. Take the last element, that is all. Color is equal to black. And actually, I need to get my list images here in this cell again with our glob. And here is the plotted image. So these are just some example images from my training dataset. And now I need to do the RLE decode. But before doing that, quick refresher on the concept of run length encoding, which is pretty much this. That is, this is a lossless compression algorithm, and it is very simple to practice on. The concept of RLE compression is that we check for the consecutive runs of the current pixel value. This algorithm works based on binary images. So let's take this example where the image is this, that is 1 0 0 1 1 1 0 0 0, this whole array, and have 16 pixel, and it is a binary image. Now using RLE, we do something like this, that is, at the beginning the current pointer is first value is 1, and now compressed image is 1 1, which means that this number 1 is repeated one time only. That's why we will be taking 1 1 for the first encoded value. Next I have 0, and again it is repeated only one times, hence compressed image will be 1 1 for the first one, and then 0 1, that is value is 0 repeated one times, that means 0 1. Then take the next one, this one is repeated 3 times, 1 2 3, that means this number will be represented in the encoded format as 1 1 1 3, that is the number is 1 repeated 3 times. That's why in this line I'm saying that the compressed image at this position will be represented by this array, that is 1 1 0 1 1 3, and so on. So that's how the finally, if we go ahead doing this kind of calculation, the final image will be represented like this array, that is 1 1 0 1, that is this whole thing. So the key point is that this original array now after the encoding is represented in a shorter format. That's the whole motivation of doing the encoding. But now I have to do the reverse process for doing the decoding. That means that each of these first position will be my pixel value, and then the next number will be my run length, that is for how many times that pixel is repeated, that is how many times that pixel is running for. And hence if I take a look at the competition pages, these data tab, we can see the segmentation is represented in this way. So the first number here, that is the pixel value, and then the next single number is a run length. That's how it is represented. So basically now that I have to write my RLE decode function, I have to capture these values, that is this will be my start position, then this is length, run length, again this will be my start position, and this is run length. So I kind of have to jump one step while looping through or iterating through these array for each image. Let's start writing the function. We'll obviously take the first argument as the RLE encoded value, that is actual encoded form. Then it will take my height of the ultimately decoded image's height and width. Sorry, that's width. Then I also need a fill value. For that I'm just passing it as 255 for now. Uh, 255 because this is actually representing the color white. There's a spelling mistake here. All right, the first I need to take the string from the RLE. Then I need to iterate through this string. So I'm going to get my start and the length of the current pixel. D type. I'm going to take int for, this is completely unnecessary. D type int for x in. I need to specify the starting position and the jump. This will start from 0 and first slice denotes only empty slice notation, colon notation denotes that I'm taking the entire, I'm starting from 0 and I'm going all the way up to the end, but the last number is 2. That means I'm jumping by 1 position. Similarly, for the next one, it will take the second dimension and sorry, it will take the now I'm going to calculate the length. That means I have to start from the second position of the array. That is, for calculating the start position, I'm starting from the very first index position of the array, but for calculating the length, I have to start from the second position of the array. And then similarly, I have to jump by 1 position, so colon, colon, and 2. I'm missing my braces here. Yep. Reduce 1 from start. This is just how the index number is calculated in Python and NumPy in generally. Mass could be equal to np.zdros height times width. And that's my shape of mask. Zip 2 arrays which are start and length. First, I'm going to assign, I have to assign the fill value between position and position plus run length. Position is like the starting position of the pixel, and run length, that is how many pixel that particular pixel is running for. So that I have to fill by my fill color, which is 255. So starting from position and up to, sorry, this will be a slice. Fill. And then come out of the loop. Mask would be equal to mask dot reshape. I need to reshape it because initially I set this mask to be this shape, that is height times width and star. Now I need to reshape it to width, then height, and transpose it. So if I calculate the mask shape here, this will be just multiplication of height and width, and our height and width in this project is, let me quickly check, that's actually 255 and 255. So here, after declaring the mask variable, here the shape will be just multiplication of 255 and 255, that is 65025. And after this reshape that I'm doing here and the transpose, now my shape will be like this, because now I'm converting it to a two-dimensional vector. And also, just for making it efficient, I'm going to do np.as contiguous array mask and return mask. That's all my decoding algorithm. It is relatively simpler than the encoding part. Actually, I made a mistake here. This mask is not start here. It's a single dimensional vector. That is, it will just be 65025 elements in this entire array. So this will just be as simple as this. That is mask equal to np.zeros height and width, and I need to make it d type of np.uint unsigned integer. And now it should be okay. Let's quickly check if it is my method is working actually. So I just got a string from the data, that is our own data set. I got a single string for a single segmentation row, which will be represented like this, that is position, run length, position, run length. And now I'm just applying my RLE decode function on this. Yes, so that's how the output will be from my RLE decode. So actually these output matrix or two-dimensional vector that we see here, this is the decoded form of this encoded variable. So this entire thing is an RLE encoded form. And now after decoding to get back the original image, this will be my original decoded image, and this will have the mask properly denoted in here. All right, now that my RLE decode function is working just fine, this is the last step that I'm going to do now, which is to actually plot the images along with the mask overlapped on the images. Let's take my image first from DataFrame. I'm going to apply a condition, and that will be segmentation should not be null. Num columns and num rows, I'm setting 3 and 2 because I need 3 columns representing a mask image and mask image overlay for these three different types of images. And rows, I'm just selecting 2 of them. Actually, select rows 4 maybe, just to check them better. Subplots. Number of rows. And now the actual loop, that is, I'll be iterating over the range of num rows. So for I in range, take a sample of images from X. This I wanted to in capital letter. X dot take integer location. I'm going to use random dot rand int. take 0, and from the shape of X, that will be my randomly chosen sample. Now height and width is as usual 255 by 255. Mask now will be, I have to extract it from the segmentation column, and the value need to be decoded. So I need to, here is where I'm going to execute my RLE decode method. Decode. The first one will be the actual masked number, that is the encoded number, and that is in my segmentation column. The next is height and width. Height, sample width. And the last one is my fill value, which is 255. Now I also need to make this normalized. So mask divided by 255 and S type int. And I need to transpose it as well. Okay, now for the plotting, the first row of the plot should contain the heading. So yeah, let's do it. If I equal to 0, that is the very first row, then access I to 0, set title. This is the first column, so I need to set the title as mask. Color, let's give it red. Now for the first column, I also need to set the Y label, that is the vertically it will be shown, and that should be my ID. Let's quickly check. Yeah, so this in my data frame, this is my ID values, which contain the case number, the day, and the slice number. So that's exact what I need to show on my vertical y-axis, that is Y label. So set Y label sample ID axis I0 show mistake image if I equal to 0. Now I am going to set the title for the second column, which will be my image, the actual full image. So let's do if I equal to 0, AX, EX. Now this one will be I and 1. This is my second column. Image color equal to red. And now I'm going to show the image actually. So I am show, and that will be my np.array. I need to convert it to a Numpy array, the image. And how I'm getting the image is because I'm capturing the value from the full path. That's the column value I'm capturing. And if we go back to our data frame, this full path column has the full image path of each of the images. So that's how I'm capturing the value here. All right, so that's image is done, and the last one that is remaining, that's my overlay, that is image along with the mask. So result image, that's, yeah, result, that would be color dot, I'm going to use label to RGB, label to RGB. For that I need to pass the mask and also the image. Now I need to divide it by np dot array image dot max value, and here also I need to set my, so that's the resultant image. It will contain both the image and the mask together over with the overlay. That is, a mask will be overlaid on the image, and so that we can actually see that where the tumor actually exists on the image. And here I also need to set the column heading. So if I and now it will be the third column, so I comma 2. Set title mask image overlay, color remains red, and need to show the image access I2 dot imshow, and I'm going to show this result image, result. And now let's run this cell. Awesome. So that's the final result I got. At the left, this column contains only the mask images. Then the middle one is only the image without the definition for the mask. And finally, the third column has the image overlaid with the mask segmentation as well. So that pretty much wraps up this video, and in my future plan over the next 2 weeks, I'll be publishing many videos around very interesting topics on NLP, fundamentals of machine learning. So stay tuned, and if you have not subscribed yet, do subscribe. If this video was useful, hit the like button. Thank you very much for watching. See you in the next one.